Stand up. I mean it. Actually get up out of that chair if you can. Bend one knee and lift the foot a few inches off the floor. Hold it there. Count 3 seconds with me. 1, 2, 3. Now most of you felt something. A small ache behind the kneecap, a tightness deep in the hip, a faint clicking sound that was not there when you were 30. Whatever you felt, that is information. That is your body sending a signal through a piece of engineering that has been running continuously since you took your first step. Now I want to tell you what is actually happening inside that joint. Because once you see the machinery, once you really see it, you cannot unsee why it is failing as you get older. And you cannot unsee why one specific kind of stress, applied correctly, reverses the failure. Let me show you what is in there. Inside your knee, the same is roughly true of your hip, your shoulder, every major joint. There are 3 things that matter. First, the cartilage. 2 layers of it, one on the end of each bone, glued tight. The cartilage is white, glossy, smooth, about 3 millimeters thick. Press your thumbnail right now. The cartilage in your knee is roughly the thickness of 2 thumbnails stacked. That is all that stands between bone and bone. Second, between those 2 cartilage surfaces, there is a thin film of fluid, maybe 2 milliliters in a healthy knee, less than half a teaspoon. This fluid is called synovial fluid, and it is one of the strangest substances your body produces. We will come to it. Third, holding the whole assembly together from the outside, there is a capsule of tough tissue, and threaded across that capsule, like cables running across the outside of a bridge, there are tendons and the big muscles of the thigh. The cartilage, the fluid, the cables, those 3 pieces. Now here is the thing nobody told you. The cartilage has no blood supply. None. There are no arteries running into it. There are no veins coming out. There are no capillaries. A piece of cartilage is one of the only living tissues in your body that is, in a sense, isolated from your circulation. It cannot eat the way the rest of you eats. So how does it stay alive? I want you to picture one cell. Buried inside that 3 millimeter layer of cartilage there is a small living thing called a chondrocyte. The chondrocyte sits in a tiny pocket, a kind of microcave called a lacuna, surrounded by the matrix it secreted around itself. There are a few thousand of these chondrocytes in every square millimeter of cartilage. They are responsible for maintaining the entire structure. They build the collagen. They build the proteoglycans, which are the molecular sponges that hold water in place. They are the maintenance crew, and there is no replacing them. Once they die, the matrix around them slowly degrades. Here is the curious thing. The chondrocyte does not respond to chemical signals the way most of your cells do. It responds to pressure. It is what the biologists call a mechanosensitive cell. When you load the joint, when you walk, when you climb stairs, when you squat down to pick up a grandchild, the cartilage compresses by maybe 10 or 15% of its thickness. The chondrocyte feels that compression. The cell membrane deforms. Ion channels embedded in the membrane open. Calcium rushes in. A cascade of signals travels through the cell, and the end result is this. The chondrocyte responds by manufacturing more matrix, more collagen, more proteoglycans. The cartilage maintains itself. Now what happens when you do not load the joint? What happens to the maintenance crew that only works when the building is being used? It atrophies. The chondrocyte shuts down. It stops manufacturing matrix. The cartilage becomes thinner, weaker, more vulnerable. This is not speculation. Daniel Bilavi and his colleagues, working at Deakin University in Australia and earlier at the German Aerospace Center, ran a series of experiments where they imaged the spinal discs of healthy adults before and after periods of bed rest, and again in adults who began structured loading programs. The cartilage and the disc tissue showed measurable changes in matrix composition, losses with disuse, gains with appropriate loading. 60 days of bed rest was enough to produce changes you could see on a scan. The cartilage in your knee is doing the same thing. Every year that you load it less than the year before, the chondrocytes do less work. Every year of less work, the matrix gets thinner. By the time you are 70, If you have lived a sedentary life, the chondrocyte population in your knee has been operating in low power mode for decades. This is why joints hurt more every year. Not because cartilage wears out from use. The opposite. Cartilage thins from disuse. But the chondrocyte is not alone in there. The same compression that signals the cell is also doing something to the fluid surrounding it. Synovial fluid is a peculiar liquid. It is mostly water, but suspended in that water is a long, tangled molecule called hyaluronic acid, chains of sugar units, each chain millions of units long, all coiled and entangled with each other. When the joint is at rest, hyaluronic acid behaves like a thick gel. When the joint moves quickly, the chains slide past each other, and the fluid behaves like a thin oil. The technical name for this is non-Newtonian. It changes its viscosity depending on how fast you stress it. Honey is non-Newtonian. So is ketchup. So, it turns out, is the lubricant in your knee. Now here is the trick. The cartilage is full of those proteoglycans I mentioned, molecular sponges, soaked with water. When you compress the joint, the water is squeezed out of the cartilage and into the joint space. When you release the load, the water is sucked back into the cartilage. Squeeze, release, squeeze, release. The cartilage breathes. Each compression pumps fluid out. Each unloading pulls fluid back in. This is called weeping lubrication, and it serves two purposes. First, the layer of squeezed-out fluid sits between the two cartilage surfaces and bears the load. The surfaces never actually touch each other. They glide on a film of fluid less than 1/10 of a millimeter thick. Second, the cycling of fluid in and out is how the chondrocytes get fed. Remember, no blood supply. The nutrients reach the chondrocyte by diffusing through fluid that is being pumped in and out by movement. Stop moving the joint, and the pump stops. The chondrocytes starve. The matrix degrades. The cartilage thins. The hyaluronic acid in the fluid breaks down. The chains become shorter, less viscous, less protective. By the time you are 60, if you have stopped using the joint with any real load, the synovial fluid is thinner than it was when you were 30. The cushion is gone. The bearing surface is gone. Bone begins to sense bone through a thinning curtain. There is a researcher named Kim Bennell at the University of Melbourne who has spent her career studying exactly this. Her group, along with collaborators across Australia and Europe, has shown in randomized trials that progressive resistance exercise, meaning loading the joint under increasing weight, deliberately over months, produces measurable improvements in pain, in function, and in some cases even in imaging markers in people with osteoarthritis. Not by repairing damage, by restarting the pump, but the fluid alone cannot keep the joint healthy. The forces that hold the joint stable, that keep the bones aligned through the geometry of motion, those forces come from outside the capsule. The knee is not actually a hinge. It is a sloppy hinge. If you took the knee apart and looked at just the bones, the femur on top, the tibia below, the patella in front, you could not stand on them. They would slide off each other. The bones do not lock together. They are held in alignment, and the impact of every step is absorbed by the muscles that surround the joint. The quadriceps in front, the hamstrings behind, the calf muscles below, the hip stabilizers above. When you step down, the muscles fire fractions of a second before the foot hits the ground. They tension the joint. They preload the cables. The bone never crashes into bone, because the muscles are absorbing the force first. Now what happens to those muscles as you age? They shrink. There is a name for this. Sarcopenia, from the Greek, meaning loss of flesh. After about the age of 30, untrained adults lose somewhere between 3 and 8% of their muscle mass per decade. By the age of 65, an untrained person has lost roughly 30% of the muscle they had at 30. By 80, the loss is closer to 50%. The muscles that are supposed to absorb the impact of every step are weaker every year. The cables holding the joint together get slacker. More force reaches the cartilage directly. The chondrocytes, already underfed because the pump is slowing, now get hammered with shock loads they were never designed to absorb. This is the picture. Cartilage thinning from disuse. Synovial fluid degrading from disuse. Muscles weakening from disuse. 3 failures stacked on top of each other. Each one makes the next one worse. The joint hurts. The person walks less. Walking less means even less loading, even less fluid pumping, even more muscle loss. The system spirals downward, and by the time the joint is hurting badly enough to bring the person to a doctor, 3 different systems are failing at once. But here is the thing. The same intervention reverses all 3. Because the muscle, when it contracts, is doing something far stranger than holding bones in alignment. It is acting as an organ of secretion. I want to introduce you to a researcher named Bente Klarlund Pedersen. She works at the University of Copenhagen, and in the early 2000s she and her group made a discovery that genuinely changed how physiologists think about muscle. They found that contracting muscle releases hormones, not just 1 or 2, dozens, maybe hundreds. We now have a name for these hormones: myokines, from the Greek for muscle and to move. When you contract a muscle hard, it secretes signaling molecules into the bloodstream. Those molecules travel everywhere in the body. They affect the brain. They affect the immune system. They affect, of particular interest to us, the joints. The most studied myokine is called interleukin-6. Now, interleukin-6 has a complicated reputation because in the context of chronic infection or chronic inflammation, it is a marker of disease. High interleukin-6 in the blood of a sick person is bad. Pedersen's group showed something different. When interleukin-6 is released by contracting muscle, in a brief pulse during exercise, it has the opposite effect. It triggers the release of anti-inflammatory molecules downstream. The body interprets exercise-released interleukin-6 as a signal to dial inflammation down, not up. There is a phrase the geriatricians use: inflammaging. It is the slow, smoldering, low-grade systemic inflammation that builds up in the bodies of older adults. Inflammaging is part of why the joints hurt. The synovial membrane, the capsule, the surrounding tendons all become more sensitive, more reactive, more painful when the body is in a state of chronic low-grade inflammation. The muscle contraction interrupts this. Each session of resistance training is a pulse of anti-inflammatory signaling. Done consistently, over months, those pulses lower the baseline. Pedersen's group, along with many others, has documented measurable drops in inflammatory markers in older adults who train. There are other myokines. Irisin, named after Iris, the Greek messenger goddess. Interleukin-15, brain-derived neurotrophic factor, which is involved in keeping nerve cells alive, including the nerves in your joint capsule that report position and pain. Each contraction of a working muscle is a small dose of medicine, manufactured by your own body, distributed by your own bloodstream. And these molecules reach everywhere. They reach the joint capsule. They reach the synovial membrane. They reach the cartilage matrix. They reach the same chondrocytes we started with, the ones we had isolated, breathing, mechanosensitive cells in their tiny caves. Now look at what happens when you load the joint correctly. A single set of squats, performed with attention. The quadriceps and gluteal muscles tension hard. They preload the knee. As you descend, the cartilage compresses by 10 or 15%. The chondrocyte feels it. Calcium rushes in. The cell wakes up. It begins synthesizing new matrix. Simultaneously, water is squeezed out of the cartilage and into the joint space. The synovial fluid, now warm and thinned by the activity, distributes across the bearing surface. As you ascend, the fluid is drawn back into the cartilage, carrying nutrients with it. The pump runs. The maintenance crew is fed. While this is happening, the contracting muscles are pumping interleukin-6 into the bloodstream. The molecule reaches the joint capsule and triggers anti-inflammatory cascades. The local environment becomes calmer. Tendons strengthen. Bone density around the joint increases. There is a reason, by the way, that resistance training is the single best intervention for osteoporosis, and it is the same reason. The bone is mechanosensitive too. Load the bone. The bone manufactures more bone. You walked into the gym with 3 failing systems. You leave the gym, an hour later, with all 3 of them having received exactly the input they were waiting for. This is not a metaphor. This is what is happening, in real time, at the molecular level, every time you load a joint deliberately. Now I want to be careful here. I am a physicist, not a doctor. I have been telling you a story that is largely true, but it has different layers, and not all of those layers are equally well established. Let me grade them for you, because I do not want to oversell. The strongest claim, the one with the most supporting evidence, is that exercise reduces pain and improves function in osteoarthritis. This is not in question. It is one of the most replicated findings in clinical medicine. The Cochrane collaboration has reviewed it many times, with thousands of participants pooled across dozens of trials, including reviews led by Marlene Franson and her colleagues. The effect size is comparable to what you get from over-the-counter pain medication, but without the side effects, and with a long list of additional benefits. If you only believe one thing I am telling you tonight, believe this one. The treatment works. The second strongest claim is that resistance training builds muscle, and that muscle stabilizes joints. This is foundational physiology. There is no controversy. The numbers on sarcopenia and its reversal are robust. Older adults can build measurable muscle mass and strength even into their 90s. The third claim, that loading the cartilage maintains the chondrocyte and its matrix, has good cellular and animal evidence, and reasonable but more modest evidence in humans. Bellavy's spinal work is real. There are imaging studies showing changes in cartilage thickness and composition with structured exercise programs. But the magnitudes are small, the timelines are long, and the question of whether you can actually grow back significantly damaged cartilage in an older human knee remains frankly unsettled. You can probably preserve what you have. You can probably slow the decline. Whether you can fully reverse advanced damage, I would not promise. The fourth claim, about myokines and the anti-inflammatory effects of muscle contraction, is the most recent, the most exciting, and the least mature. Pedersen's framework is increasingly accepted. The interleukin-6 pulse from exercise is real and reproducible. But the precise mechanisms by which this affects joint pain in any individual, the dose response, the timing, these are still being worked out. Take this part as the most likely correct, but the most subject to revision in the next 10 years. So that is the calibration. The treatment works. The mechanisms are partly proven and partly under investigation. The story I have told you is true at every level, but the lower levels are still being mapped. Now I want to compare this with what you can buy, because once you understand what is happening in the joint, the pharmaceutical landscape begins to look different. The first thing your doctor will probably suggest is a corticosteroid injection. Cortisone. The shot goes directly into the joint. The cortisone is a powerful anti-inflammatory, and the relief is often dramatic. The joint feels better within days. The mechanism is the suppression of the inflammatory cascade in the synovial membrane. Notice that this is the same outcome the muscle contraction was producing through interleukin-6 and downstream signaling. The cortisone shot is a sledgehammer version of the body's own pulse dose intervention. It works fast, it works hard, and it has a price. Repeated cortisone injections can actually accelerate cartilage degradation in some people. The body's version, delivered by your own muscle, is gentler, slower, and does not damage the cartilage. It also does not cost $300 per shot. The second thing you will be offered is a hyaluronic acid injection. They are sold under various brand names. The price is typically several hundred to over $1,000 per knee, per round. The molecule being injected is the same molecule we discussed, long chains of sugar units that act as a non-Newtonian lubricant. The pitch is that the synovial fluid in your aging knee is degraded, and we are replacing it. The data on whether this works in the long term is genuinely mixed. Some people get real relief. Some studies show effects barely above placebo. But here is the curious thing. The body's own production of high-quality hyaluronic acid is stimulated by, yes, joint loading and movement. The synovial cells that line the capsule manufacture more and better hyaluronic acid when the joint is being used. The injection is, in a sense, a substitute for what the joint would manufacture itself if it were being asked to. I am not telling you to refuse these treatments. There are people for whom the cortisone shot is the difference between sleeping through the night and not sleeping. There are joints in which the cartilage is so far gone that exercise alone will not be enough. Knee replacements exist for a reason, and for many people they are exactly the right answer. The pharmaceutical and surgical options are not bad. They exist because they help people. What I want you to see is that the loading-based intervention, the one that costs nothing but effort, is operating through the same molecular pathways. It is a slower, milder, more sustained version of the same mechanisms the drugs are crashing through. And it is the only version that simultaneously rebuilds the muscle that holds the joint, increases the density of the bone supporting it, and lowers the inflammation in the rest of your body. The exercise is not an alternative to medicine. The exercise is the medicine, prescribed by physiology, manufactured in your own tissue, distributed in your own blood. I want to talk for a moment to a particular person. Maybe it is you. Maybe it is someone you love. The person is 67 years old. The right knee has been hurting for about 3 years. The doctor said arthritis. The advice was to take it easy, to walk, but not too much, to avoid stairs, to rest when it hurts. This person took the advice seriously. They walk gently on flat ground 2 or 3 times a week. They have stopped gardening because kneeling hurts. They have stopped picking up the grandchildren because lifting from the floor hurts. The knee, in spite of all this rest, has gotten worse, not better. Now you understand why. Every month of taking it easy was a month of the chondrocytes going quieter. Every month of avoiding load was a month of the synovial pump slowing. Every month of not lifting things was a month of muscle loss in the quadriceps. The advice was, with genuine kindness and the best of intentions, accelerating the decline. This is not the doctor's fault. The science I am describing was not in the medical school curricula 30 years ago. The full picture of joint biology has come together only in the last 20 years, and it is still working its way into clinical practice. The advice older adults receive today is, in many cases, advice that fits the science of the 1980s, not the science of now. If you are that 67-year-old, the intervention is not to ignore the pain. It is to find a physiotherapist or a clinician familiar with progressive resistance training for osteoarthritis. Iwa Roos and her colleagues at the University of Southern Denmark have published a program called GLAD, Good Life with Osteoarthritis in Denmark, which has been studied in tens of thousands of patients and is built on exactly the principles I have been describing. It is being adopted in clinics around the world. Find someone who knows it. Begin slowly. Load the joint progressively, under guidance, over months. The pain you feel in the first weeks is not the enemy. The pain is information. The pain is the joint complaining about a request it has not received in years. The complaint quiets down as the system relearns how to handle the load. I want to be very clear about what this is and what it is not. It is not walking. Walking is good for many things, but walking on flat ground at a comfortable pace is, from the chondrocytes' point of view, almost no information at all. The compression is too mild. The duration is too brief. The load is the same load you have been giving the joint for decades. It is not stretching. Stretching does not reach the chondrocyte. It does not run the pump. It is not yoga, although yoga done with weight-bearing positions overlaps. It is not low-impact aerobic exercise on a stationary bicycle, although that is good for many other systems. It is, specifically, the deliberate loading of a muscle and the joint it surrounds, against a resistance significant enough to challenge the muscle, repeated until the muscle is genuinely fatigued, and then done again, 2 or 3 times a week, for the rest of your life. There is no shortcut. There is no equivalent. There is no pill, as of this moment, that produces the same suite of effects in the same tissues. Now I want to tell you something a coach said to me once, many years ago, when I asked him about an old injury that was bothering me. He said, "Move it or lose it." That was the whole sentence. Move it or lose it. He was not a scientist. He had never heard of a chondrocyte. He had never read a paper on synovial fluid mechanics. He had never met Benty Pedersen and would not have known a myokine from a pothole. But that simple sentence, move it or lose it, is the most accurate 3-word summary of joint physiology I have ever encountered. Because the joint, as I have been telling you, is not a machine that wears out. It is a tissue that adapts. It adapts to what you ask of it. Ask nothing, it gives nothing back. Ask gently, it maintains. Ask seriously, with progressive load, week after week, year after year, it builds. The cartilage thickens. The fluid thickens. The muscles thicken. The bone thickens. The inflammation calms. The pain quiets. The grandchildren get picked up. The coach was right. The physiology is exactly his sentence, written in molecules. Now stand up again. Or, if you cannot stand right now, sit forward in your chair and press both feet hard into the floor for a count of 3. Press, press, press. Now release. Whatever you felt, the tightness, the click, the small ache, that is the request. The joint is asking, the cartilage, the fluid, the muscles, the molecules in your bloodstream, all of them are waiting for you to answer. The answer is load. Slow, progressive, patient, deliberate load. 2 days a week. For the rest of your life. Begin tomorrow. Move it or lose it. So tell me, has a doctor ever told you to take it easy on a joint that has been hurting? What happened next?